Hello everyone. This is day 8, question 1 of our Leetcode activity, Fibonacci number. So Fibonacci series is a famous series of numbers which goes something like the first two numbers are 0, 1. So these are fixed 0, 1, and number every next number is sum of the previous two numbers. So these both are fixed. So 1, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So this is known as Fibonacci series, where every number is sum of previous two numbers, and the first two numbers are 0 and 1 fixed. So they are asking us to set up a function where 0 is 0, f of 0 is 0, f of 1 is 1, and f of n is equal to f of n minus 1 plus f of n minus 2, which is actually the equation for Fibonacci series. So given n, calculate f of n. So we'll first discuss the recursive approach. So the pseudocode for recursive approach is function f of n. If n is less than equal to 1, return n, or else return fib n minus 1 plus fib n minus 2. That is this is our base case, that if we hit n equals to 0 or 1, we return n, or else we will return fn minus 1 plus fn minus 2. So how does this operation take place? Here f of phi, if we call f of phi, it will call f of 3 and f of 4. Again f of 3 will call f of 2, f of 1. Then f of 2 will call f of 0, f of 1. Here f of 4 will call again f of 3, f of 2. F of 2 will call f of 1, f of 0. F of 3 will call f of 2, f of 1, and again f of 2 will call f of 1 and f of 0. So here this is the base case. So this will return 1. This is a base case. This will return 1. This is a base case. This will return 0. So here these both are added. So here it will be 1. So this will return 1. Again these both are added. So this will return 2. Again here this is base case, so this will return 1, this will return 0, this is added, so this will return 1, again this will return 1, so added, so this will return 2, this will return 1, this will return 0, this both are added, so this will return 1, added, this will return 3, and at last this both are added to get our answer 5. And this is how the calculation or the operation will take place. So this is the logic, but here you can see that this tree is branching into two, two branches for every number on average. So this will grow exponentially. This time complexity will be exponential, almost 2 raised to n. But for constraint which is small enough, this approach is valid. But as constraint grows, this recursive approach tends to fall short. So for that, we have this approach, which is our iterative approach. Here, instead of calculating f of n recursively, as you can see here, many things are being called twice. F of 3 is called here, f of 3 is called again here, f of 2 is called here, f of 2 is being called again here, and f of 1, f of 0, these all these function calls are being done repeatedly, which is causing our time complexity to shoot up to exponential very quickly. So what we can do instead is declare our function f of n. If n is less than equal to 1, return n. These are our base fixed cases. And if no, if n is greater than 1, what we do? We do we declare two variables, int previous and int current. And initially int previous is 0, int current is 1, as these are both our first two numbers. Now we apply a for loop, which int I is equal to 2 and I less than equal to n, I plus plus. Int next is equal to previous plus current. So this is a temporary variable where we are calculating the next number, as next number is sum of previous and current. Now again, previous will become current and current will become next. So here you can see that if n was equal to 5, firstly previous and current were 0 1. Now I is equal to 2. So for I is equal to 2, there is also next. Next will become 1. Now previous will become current. So this will become current and current will become next. Now again I is equal to 3. Next will become 2. So previous will become current. Current will become next. Now I is equal to 3. I is equal to 3 not. I is equal to 4. So next will become 3. This will become current and again this. And at last next will become 5. This will become 3 and this will become 5. And as we reach n equals to 5, we return current, which is 5, and which is the exact value we found here. F of 5 is 5 and the exact value we have found here, f of 5 is 5. But this time complexity is O of n, as it is our iterative approach. We just run O of n operations for n input size. So these both were two approaches, one recursive and one iterative approach for the Fibonacci number question. Thank you.